Good morning, grade nines. Good morning. It's a very good morning. What happened is simple. I know most of you are not used to being up at this time, but yeah, our timetable has changed to this time. If you can actually let other classmates if we can actually make other classmates aware that we have moved to 9 a.m. I would really appreciate that. Grade nines. Remember that last week, grade nines, we did a lot of electricity. We learned about a lot of things, new terms and everything. And today, what are you going to learn about is the following. You are going to learn about the following, grade nines. You will learn about what is um, a national electricity grid, and you will also know what a power surge is, and you also know a grid overload. And then grade nines, as I did explain to you, or did mention to you that in 2 weeks' time, as an online school, we will be actually having our online assessment. So it is very important for me to actually go and check on the first term work and the second term work. So what I'm saying is that from tomorrow, I will be actually now starting to from tomorrow. I will be starting with the first term revision, grade nine. So please use my social media handles, and then to actually uh, request the parts that you actually need us to look at. Without any waste of time, grade nines, let us look at what we need to do today. Remember that last week we had a homework. So in our homework, we had to you were asked to define the following terms: radioactive radiation, national grid, and gamma radiation. Remember that these terms came about as we were doing the nuclear power electricity. We were studying about the nuclear plant in the Western Cape. We understood from last week why did they actually position the power plant in the Western Cape, and we also learned about the nuclear disposal that takes place in the in the Northern Cape. Why are they actually taking it to the Northern Cape? Remember, we also learned about the side effects or the health effects of the nuclear waste or the nuclear power as a whole. So you were asked to define the following terms: radioactive. So what is radioactive, grade nine? Radioactive is emitting or what? To emission of ionizing radiation radiation or particles, grade nine. Remember that we learned this new term last week when we were actually doing our first part of nuclear. So we're going to continue with it. Then we also learned of the new word that is radiation. What is radiation, grade nine? So now the radiation is the emission of energy. Remember that when we talk of electricity, we also had talk about energy, and then remember we spoke of mechanical energy changing to electrical energy, and then chemical energy to mechanical, and then mechanical final to electrical energy, where we get the product, and then our energy differs from instrument to instrument. Others will give off noise, others will give off heat, so on and so forth. So radiation is the emission of energy as electromagnetic as electromagnetic, and then waves. So now we're talking about waves or as what? As moving subatomic particle, as moving subatomic particles as subatomic particles, especially high energy particles which cause ionization. So we'll just end it there. Then I want to now look at the national grid. Last week we spent the whole day talking about national grid. So what is actually the national grid? The national grid grade 9 is the network of high voltage power lines between major power station. So it is the network of high voltage power lines between major power stations. Are we clear, grade 9s? So that is the national grid. When we're talking about national grid, we are talking about the network of high voltage power lines between major power stations. So that's how the electricity gets transported or dispersed around the country. Then what is gamma radiation? So they say gamma radiation is a penetrating, I hope you are marking your work, grade 9s, penetrating electromagnetic radiation. We already know what is the radiation. Electromagnetic arising from the radioactive decay, radiation. Okay, radioactive decay of atomic nuclei nuclei. That's what I needed you to write there. I hope you've done your corrections now. We said that we have radioactive, and then radioactive is obviously that. Then we said that radioactive is emitting or relating to emission of ionization radiation or particles. Radiation, the emission of energy or as electromagnetic waves or as moving subatomic particles. And then when we're talking about the national grid, we're talking about the network of high voltage power lines between major power stations. When we're talking about gamma radiation, is a penetrating magnetic radiation arising from the radioactive decay or of atomic nuclei. Remember, when we're talking about the nuclear power station, we're talking about the nuclear energy, and then once the nuclear waste and then is now done, we're done with using it in a process, we call that nuclear waste, and then it needs to be disposed elsewhere. Let us continue with our corrections, grade 9. Let us look at the second part. And then the instruction there is simple. Go through the notes and answer the following questions. So I gave you notes on Friday, and then now they say to you, explain why the Goldberg Power Plant was built in the Western Cape. Why did we build the Goldberg Power Plant in the Western Cape? It is because the generation of electricity requires a lot of water, and Western Cape has a high annual rainfall. Are we clear? That's why we have our nuclear plant in the Western Cape, because there we have a high annual rainfall. Then they say which element is used in nuclear reactors. So last week we spoke of this element. It's uranium. Uranium. It is that element that is mostly used in nuclear reactors. We need this uranium because when it's split, it gives off a high energy. What health problems are associated with nuclear waste? Grade 9, the health problems that are associated with nuclear waste are simple. We spoke of cancer. We said cancer. We said genetic mutation. When you're talking about genetic mutation, there is Yoliswa. Someone is in my class. Hey, good morning, Yoliswa. Mutations and Yoliswa. Oh, Yoliswa. We have genetic mutation there, and what? And bends. So these are problems associated with nuclear waste. Actually, that's why it needs to be disposed where it actually cannot the gamma waves cannot work. Actually, they are stopped from penetrating or being in contact with human beings or plants. Then they say to you, explain how nuclear waste is handled in South Africa. How nuclear waste is handled in South Africa. That's what you need to explain, grade 9s. So the nuclear waste in South Africa is handled as follows, grade 9s. How is it? Remember that we need to make sure that it does not affect the plants, the human beings, so on and so forth. So now they say to you, how is it managed, the nuclear waste? How is the nuclear waste managed in South Africa? Anyone with an answer, grade 9s? How do you think it is managed? So the nuclear waste in South Africa is managed as follows. Yes, Yolisa. So
Hi sir.
yes, morning, Yolisa.
How are you, sir?
I'm well, thanks, and you?
So sir, I'm good. Sir, the South Africa they transport in South Africa they transport the waste on trucks to
Yes.
Valsputs. I don't know how to pronounce that, in the Northern Cape, where it is buried underground. The
Thank
nuclear waste is buried in large concrete vaults underground.
Yes, thank you so much. So, why did they choose the Northern Cape?
Because there's less rain, sir.
Yes, thank you very much, Lisa. So let us phrase that. So we'll say the nuclear waste, in South Africa, is transported from Western Cape to Northern Cape Northern Cape where there is a low annual rainfall and it is buried underground where it is buried underground where underground in concrete. What? Where's your list? He's not assisting me. Buried underground in large concrete vaults. Concrete vaults. So remember, why is it important to be concrete vaults, grade 9? Because this Gamma rays cannot penetrate through they cannot penetrate through they cannot penetrate through concrete. They cannot penetrate through concrete, grade 9s. Let us continue grade 9s without any waste of time. I hope no one has questions. There we go. So today, as I promised, we are looking at the following. We are looking at the national grid. We already know, we said national grid obviously are the power lines between very, very high voltage lines, then now to substations. Yes, so they say a national grid is the network of all electrical transmission lines in South Africa. It is the the transmission of the network. I'm sorry, it is the network of electrical transmission lines in South Africa, grade 9s. You need to bear in mind that. So they say the power stations, grade 9s, what do? The power stations all over South Africa are linked by transmission lines and towers called pylons. They are called pylons. So the transmission lines transmit, or they send electricity from one place to another. They send from one place to another. Remember, we know now that the nuclear power station in Cape Town is responsible for 5% of the country's electricity. And they said the projections are that by 2030, we will have actually 13% from that power plant, the nuclear plant in the Western Cape. So how will we get that electricity across the country? It will be through a national grid. It will be through the national grid, grade 9s. So it is important for you to know what are national grids. And then let us continue, grade 9s. Thick aluminum and copper wires make the process of transmission possible, and those we call them we call them the cables. That's why when we don't have electricity, we will say actually they stole the cable. We will say they stole the cable. We will say they stole the cable, because, or then we call that we will call it the cable. The cables are the thick aluminum and copper wires, grade 9s. I'm sorry, I'm a bit distracted there. I'm sorry. The network of all the South African of all the transmission lines in South Africa is called the national electricity grid. Are we clear, grade 9s? The network of all the transmission lines in South Africa is called national electricity grid. The national grid is a network of interconnecting parts. Interconnecting parts. That's what we call this. Then grade 9s, they say a change in one part can affect other parts of the grid. Power stations feed electrical energy into the national grid and at high voltage. Power stations feed electrical energy into the national grid at high voltage. That's why we will need the substations where the voltage will now actually experience the resistors. The resistors in terms of those cables, and then in terms of we're having ammeters now to say this is how much electricity you need to distribute, this is how you need it, and then that's when the connection of the resistors or the components of the circuit will come into party, whereby now you will actually get to say, okay, I'm going to connect this in series, or I'm going to connect this in parallel, so that I can actually get more more electricity across. Then they say the electricity in transmission cables, cables, there is this word we are all used to in transmission cables, needs to be at high voltage and low current. If we've got high voltage, we're going to have a low current, grade 9. So now what is important, grade 9, is to remember that current is obviously the energy that is flowing through the cables. We said the current is also known as kinetic energy, but when it's still at the power plant, it's still stored there, it has not been distributed, we say it is a potential energy. Please, grade 9s, remember those words, remember those terms, grade 9s. If the current is too high, the cables could melt. So remember what happens when the fuse in your gadget or in your electrical appliance do. If the fuse melts, then the current can no longer flow, and then we say that thing is damaged. So same applies here. If the cable melts, so what's going to happen? It will mean the energy distribution or the energy transmission is affected, grade 9. So if the current is too high, the cables could melt. So this statement on its own, it is telling us that if the current is too high, then we will have a problem with the electricity supply. We'll have the problem with the electricity applied. If the voltage is too low or insufficient energy will reach home. So that means no energy will be reaching homes. Some 15% of energy is wasted due to heating, transmission lines, and transformers. However, that's the good waste because sometimes we need that to actually have the transformers working, to have the energy being distributed across. So we need to actually waste that 15% of energy for a good cause, grade 9. Grade 9, let us continue. I hope you are with me. If I'm moving too fast, remember the rule still applies. You raise your hand and then I will slow down. They say to you, grade 9s, for this reason, a high voltage is transmitted to ensure that there is still enough electricity in cables when it reaches its destination. Remember we said the longer the cable and the broader the cable, those are the things that actually affect the flow of current. So if the cable is long, the length now, remember we said three things affect current, the flow of current. It's the thickness of the resistor, it's the length, how long is the resistor, or the conductor, the thickness of the conductor, the length of the conductor, and obviously the heat. You remember we spoke about that, grade 9. I remember very well earlier on. So now for energy to reach its destination sufficiently, we will need the voltage to be a bit high. That's why that's what the first statement is saying. And then they move on to say power stations produce electricity at about 20,000 volts. It's very high, 20,000 volts. This is transformed to even higher voltage by a step-up transformer. We've got now a step-up transformer that obviously from the main station to substation. So at the substations, the current gets there, it is almost tired, and then we get what? A step-up transformer, and then a step-up transformer rejuvenates the energy to actually, or it rejuvenates the current flow so that it reaches its destination still active. So we've got step-up transformers that make sure that it doesn't get actually it doesn't get tired, the current that is. Grade 9, they say power lines often carry a sign warning of the high voltage. We all know that. Even if you can go to a substation, you'll see ingozi danger hever, and then they will write volt. Then that's why, because it is in high volt, and then you cannot just touch it anyhow. You need to be knowing very well what you're doing there and why are you there, actually who sent you, because you can get electrocuted there. So you need to be very, very aware when you get there to the substation. I don't know what you'll be doing there, but you need to be protected and knowing what exactly is. So now we are now aware of the power, national power grid. Then now let us look at the power surges, grade 9. What are power surges? A surplus of electricity when a voltage is 110% above the normal voltage in the power lines. The national grid is constantly connected to every part of the grid. The national grid is constantly connected to every part of the grid. Remember, we said the national grid is actually the power lines that are interconnected to supply the energy across, right? Then if the problem occurs in one part of the grid, the effects are felt all over the grid. So now if there is a problem in one grid, then all other grids will obviously either fall off or they will now receive more a voltage, and then the effects are felt everywhere. Are we clear, grade 9s? Then the two main problems that disrupt power lines or power supply, grade 9s, are simple. They say in the national grid are power surges and grid overload. Power surges and these are responsible. It's power surges and grid overload. So if there is a breakdown, in one part of the grid, the electricity is redirected to the other part of the grid. If there is a breakdown in one part of the grid, the electricity is redirected to the other part of the grid. Hence, I said to you, if the grid is disturbed from one part, when it can no longer transpose or obviously transmit the current will be directed elsewhere, where it will obviously be at high voltage, grade 9s. It will be at high voltage. So for each lost branch of the grid, the remaining branches take on more power and experience an excess of electricity. So obviously, if there's more, that could actually also be a problem. That's why we will need resistors now that we actually will limit the flow of current. Grade 9s, that's when we'll have the earth, that's when we'll have the fuse, that's when all those components I spoke of will come into parts. Grade 9s, they say this results in what is known as power surge. A power surge occurs when a voltage is 110 above normal. Okay, we've been there. And then they say many electrical appliances in the home can be damaged by power surges, grade 9. So a power surge, grade 9, an example of a power surge, grade 9, it's what we've grown to be, we've normalized as the South African. It no longer scares us as a load shedding. I'm sorry, load shedding. I take load shedding as a power surge because now remember, with load shedding, what happens when the electricity is gone and then they tell you you'll experience this for 4 hours, and then what will your parents say? They will say, switch off from the wall. The TV, switch it off from the wall. That's why it is there. James, your hand is up. Okay. Then they say any appliance or device that contains a microprocessor can be damaged by a spike in electricity. So now when they lift up after load shedding, then the current start flowing back into our houses. What happens is it has an extra spike. Then that's why I will get our TVs and microwaves, fridges being damaged, because now it will be a very high voltage, or the current will flow in a high voltage, and then the fuse and whatever it is in there that is meant to control electricity or current flowing in, and then it will just cut it off, to say, because if it doesn't cut it off, though, it can lead to fire. Even small change of 10 volts can damage the digital components in microprocessors found in TVs, cordless phones, and computers, etc. I think I've just explained all of that, grade 9s. So large power surges can cause immediate damage and melt wires and plastic in the electrical circuit of appliances. I've made example of our flat screen TVs that are easily affected by power surges or load shedding. We clear, grade 9s. And I see there are no questions. That means I'm moving at a very, very good pace. So now let us look at the grid overload. We spoke of the national grid, we said those are the power lines that are interconnected in supplying the actually electricity or current across. Therefore, now let us look at the grid overload. What are we talking about when we are talking about the grid overload? Then they say if too much electricity is used at the same time, there is an increased load on the supply. Remember, I said the more you connect your components in parallel, the more the demand of electricity. So what does that mean? It means the more the components, the more the demand of electricity, and then now the cell or the power station will release more current. So now they say if too much electricity is used at the same time, there is an increased load on the supply. So if this is on the supply grid. So this is obviously evident. You have all been watching TV at some point in time, and then you see a message there at the bottom of the screen saying, please switch off the lights in the rooms that you are not using, switch off the stove, switch off the geyser and all. It is because the supply grid is now being strained, and then the electricians can see that. That's why that message will pop up there saying, switch off in their bedrooms that are not being used. So when this happens, the national grid becomes overloaded from too much electricity flowing through it. Remember, if there's there's a high demand of energy, what will happen to the cables obviously transmitting energy? They will get hot, the kinetic energy. Then what will happen? Then that means it will be affected, and then it will cause a power surge. It will cause a power surge. So then they say this can cause a breakdown in a substation. Then you'll hear people saying, oh, our power station is not working because it bent yesterday. It was because it was being overloaded. It was a grid overload, and then it caused a power surge. So they say to you, the grade nines, if too much electricity is used at the same time, there is an increased load supply. Remember that, grade 9. So I can ask you in a give correct scientific term. I'll write this statement, and then you need to know that is a grid overload. So if this happens, the power supplied in that area will be cut off and blackout will occur. We know this as a load shedding in South Africa. This is what we call load shedding. You see, we will blame the government of load shedding. However, we are the ones who are responsible for load shedding. The way we're using electricity, the way we actually put people in our bedrooms, in our cottages, then it will actually require more energy usage, and then we'll experience this will experience load shedding, and then we'll start saying the government is not doing enough, while we as the people are not actually using electricity wise. A blackout is the short or long-term loss of electrical power to an area. So a load shedding, we can say a load shedding is the short or long-term loss of electrical power to an area. Depending on the cause of the blackout, restoring power is often a difficult process. That's why they tell us that you will have a 1 hour load shedding or 4 hours or 5 hours, because now taking that switch up, or it's not that easy. It is not that easy, because at first you need to determine what caused the blackout first, then you need to work on that. Then that's why when they will tell you that now there is a high demand of energy, then now you can switch off the rooms that you are not using, switch off the geysers and then all that, because they will be trying to work on the problem that why do we have so much demand all of a sudden, grade nines. Then grade nines, I think you are now clued up when we're talking about electricity at grade 9 level. I don't know if you've got any questions, because I need to continue to the second part of our lesson, which is term 1 revision. We are doing it for the exam. But with electricity, we are still going to come back here immediately after the exam. We're going to come back to electricity. What I want grade 9s is this. We are going to do term 1 revision for a simple reason, because we all know that our mid-year exam is term 1 and term 2 work. So those of you who have joined us later, because we've been here since March and others April, and then others joined us in May, and then now others are joining us now in June. So, but I will try and actually be as brief and exam question paper driven to actually do your revision starting from tomorrow. But this is what I want you to look at, grade 9s. This is your homework. In your homework, I want you to name the smallest part of the smallest parts that an animal is made of. Number 2, name the smallest part that the plant or that a plant is made of. Do you think that the smallest parts of plants and animals look the same? Give a reason for your answer. Give a reason for your answer, grade 9. I know most of you are going back to school next week, since all the schools were told not to come back this week. So we'll still be together throughout the week. If you still need more information, there are the helpful links there we've got, and then you can follow us on our pages. But tomorrow we will be looking at yes. Let me go back to the homework before anyone. Yes, I see hands are being raised. What's the matter, grade 9? Talk to me, grade 9. Yes, you can talk.
Sir, I
Yes,
just want to go back to the homework. Thank you, sir.
all right. You see, I can read your minds, my kids. So tomorrow we will be doing Unkabetsi. You joined in late. What's wrong with you, Unkabetsi? Unkabetsi? Your hand is up.
I overslept.
You see, it's -5 marks when I'm marking your exam.
No, sir, when you're writing a test, I'll wake up earlier.
Okay, thank you so much, guys. I see you tomorrow. Please write that homework, and then we will be doing everything from the cell to the systems to everything. We will be doing it. We're starting from tomorrow. I've got great slides done for you, grade 9. So please be early. Tell your other classmates that we are actually now have been moved to 9 a.m. To 9 a.m. We are no longer at 11. We are now at 9 a.m. I'm hoping it's for the rest of the week. And please actually tell your classmates also to subscribe, not so that we can learn together. Thank you so much. Have a great day further. Please do your homework. Bye, everyone.